to a decimal place. Before we get started, I got a little joke for you. What did the students say when the witch doctor removed his curse? Hexagon! Pretty funny, right? Hexagon, which is a six-sided polygon. All right, so we have to estimate some angles here. We've been talking to kids about putting in different 90 degrees, 180, 270, etc. to help us estimate. So this would be 0. I'm going to throw in my 90. The kids know how to throw in 45s as well, but we don't need it because this angle is greater than 90. So I'll throw that 45 in later. Here's 180. Here is 270. Now this angle measure is between 180 and 270. So then I'm going to throw in the 45. 180 plus 45 is 225. And I can see it's a little bit greater than 225. So half of 45 would be 22 and a half. So I'm going to add about 14 here, 15, and say this is about, and I'm going to estimate 240 degrees. Again, we're just estimating. We could get a protractor out and get the exact measure, but we're trying to come up with strategies to estimate angles. For this one, to help us out, it's not set up as nice where 0 is off here. This is kind of off kilter a little bit, so we've talked about rotating our paper. So then I have the 0 degree. I'm going to throw in 90. I'm going to throw in 180. And this angle is between 90 and 180, so this is where I'm going to throw in my 45 and get 135. And it's a little bit, it's closer to 135 than 180. I'm going to maybe add 10 degrees, so I'm going to estimate about 145 degrees. I'll be pretty lenient, like within 10, 12 degrees either side of the actual angle measure. So my goal is I want to see, they can show me and they understand the concept of estimating angles if they're throwing in the 90, the 180, the 270, and then throwing in a 45 between the two 90s that the angle falls. So that's what I'm looking for. I'm kind of sometimes off with my 45 degrees and it makes my estimate not as accurate, but that's kind of how that goes. Now, the second portion that we're going to talk about is solving first-degree algebraic equations. Like order of operations. Order of operations, first you do the grouping symbols, parentheses and the like, and then we do exponents, then multiplication and division are equal, we go left to right, and addition and subtraction are equal, go left to right. But not every problem has all of those things. So you just go in order, but you may skip some steps because they're just not in the problem. That's kind of where we're at. You'll see some of these problems have parentheses and some of them don't. But there is an algorithm, a step-by-step procedure. The first step would be to remove grouping symbols. We do that with the distributed property, but there's no grouping symbols, so we move to the second step, which is multiply the entire equation by a common denominator. There's no fractions here, so we skip that step. Step 3, we want to combine like terms on the left. There's only one term on the left, so we can't combine with anything, and there's only one term on the right we can't combine. So we go to step 4, which is transpose. With transposing, we first want to deal with the variable. We want to get all the variables to one side of the equation, which they're all on the left. And then we want everything else on the opposite side. In this case, everything's on the right. So step 4 is done for us. The final step is divide by the coefficient. Now that's a lot to say in the texting world we live in. So we say DBTC, baby. The coefficient is everything other than the variable. In this case, the variable's m, so everything other than the m is 7. The reason we want to divide by 7 is because we don't want to know what 7m equals. We want to know what m equals. And any number divided by itself equals 1. So the 7's cancel. But in order to maintain this equal sign, whatever we do to the left side, we have to do to the right side. So the 7's cancel, and I get 1m. When there's nothing in front of the m, we know it to be 1. If it were 2m, there'd be a 2 here. If it was negative 5m, there'd be a negative 5 here. When there's nothing, we understand it to be 1m. So I'm just going to put m, and 28 divided by 7 is 4. And I can plug this back in. 7 times 4 equals 28. So m equals 4. Again, go through the steps. If the kids just say these steps in their heads, they'll get familiar with the steps. There are no grouping symbols. There are no fractions. We can't combine k's with numbers. We can combine k's with k's, x's with x's, numbers with numbers, but we can't, these two are not like terms, so we can't combine them. There's only one term on the right. So step 4, we have to transpose, get all of our variables. So we deal with variables first. All of our variables are on one side, they're on the left side. We have to get rid of everything else. What can we add to 7 to make it 0? The opposite of 7, negative 7. 7 plus a negative 7 equals 0. Whatever I do to the left, I do to the right. This cancels out, and I get 6k on the left. 25 minus 7 is 18. And the last step, I've transposed. All the variables are on one side, everything else on the other. Last step, DBTC, divide by the coefficient, 6. The 6's cancel, and I get k equals 3. 6 times 3 is 18, plus 7 is 25. So k equals 3. No parentheses, no fractions. I can't combine like terms on the right. I need to transpose. All my variables are on the right. I got to add a negative 4 to both sides to get rid of everything else with on the variable side. This cancels, and I get 14 equals 7j. DBTC, divide by 7. The 7's cancel, and I get j equals 2. 7 times 2 is 14, plus 4 is 18. All right, step 1, remove grouping symbols. We do that with the distributive property. So the distributive property, A parenthesis B plus C. We distribute the A to the items in the parenthesis. A times B is AB, plus A times C is AC. Here's an example, 2 parenthesis 3 plus 4. Now in this parenthesis, there's like terms. You can combine 3 plus 4, that's 7. When I have a number next to a parenthesis, I multiply. 2 times 7 is 14. Now let's see if the distributive property will give us 14 as well. 2 parenthesis 3 plus 4. 2 times 3 is 6, plus 2 times 4 is 8. 6 plus 8 is 14. I get the same thing. The reason we need the distributive property is because sometimes in the parentheses we don't have like terms. I can't combine 6 with t. So I have to use the distributive property. 4 times 6 is 24, plus 4 times t is 4t. That equals 36. Step 2, multiply everything by a common denominator. Well, there's no fractions. Combine like terms on the left. I can't combine. These are not like terms. So then step 4 is to transpose. Get all my variables on one side. They're all on the left. Get rid of everything else. Add a negative 24. Whatever I do to the left, I do to the right. I get 4t equals 12. Final step, DBTC, divide by 4, divide by 4. The 4's cancel, I get t equals 3. 6 plus 3 is 9. 9 times 4 is 36. All right. The last problem, I have 2 grouping symbols, 2 parentheses. So I'm just going to go left to right. 4 times x is 4x. Got to use the distributive property to eliminate the grouping symbol. Plus 4 times 5 is 20. That equals 8 times x is 8x. Plus 8 times 1 is 8. I don't distribute the 8 to the 2 because it's not inside the grouping symbol. But I have to just add on plus 2. There are no fractions. I can't combine x's with numbers on the left. However, I do have like terms on the right. I can combine 8 plus 2. So I get 4x plus 20 on the left. I get 8x plus 8 plus 2 is 10. Step 4 is to transpose. I don't have all my variables. Remember, when we transpose, we're going to deal with variables first. I have variables on the left, and I have variables on the right. Now, I have to get rid of them on one side. If I were to get rid of them here, I'd have to add a negative 8x to the right, and then I'd do the same to the left. But you would notice that 4x plus a negative 8x will give me a negative 4x. So then I'm dealing with coefficients that are negative numbers. Now, the kids know how to divide integers, so that wouldn't be a problem. But I'm going to coach them to remove grouping symbols on the side where I have fewer. Because if I add a negative 4x to both sides, I'll end up with a positive coefficient. This cancels to no x's, right? 4x plus a negative x. I get 20 on the left. 8x plus a negative 4x would be a positive 4x. So now I have a positive coefficient plus 10. So the first part of transposing is getting all the variables to one side. They're all on the right side now. I have to get rid of everything else. So I add a negative 10. Whatever I do to the right, I do to the left. This cancels, and I get 4x equals 10. DBTC is the final step. Divide by the coefficient 4, and I get x equals 10 fourths, which is equal to 5 halves, which is equal to 2.5. If I plug 2.5 in to x in both of these places, I would get the left side equals the right side. Because of time, I'm just going to know that that's how that works. All right. The right side deals with understanding place value and how to write words and round. So the first thing is when we come to writing this number, I'm not going to be so much worried about spelling, but these other things I'm going to mention is what I'll be worried about. The decimal is the only time I use the word and when I'm writing. This first comma is thousand, and the second comma is million. So then to write a word, I just have to know up to a 3-digit number. This, in front of this comma, is 22. So I'm going to write 22. And then this comma means million, so I'm going to write 22 million. And since I have a comma, I'm going to put a comma in my writing. And then this 3-digit number is 25. So 25. This comma represents thousand. So 22,025,000. And since there's a comma, I'm going to put a comma. I made a typing error here. I'll tell the kids to remove this 9 when they get this paper. This 3-digit number is 134. This is the only time the next is the decimal. That's the only time you'll see and in this writing. So right now I'm at 22,025,134, and most of the kids that don't get an 8 on their learning target, they get a 5, where I don't feel like they understand the concept yet, is writing the decimal. What I'm telling the kids to do is to take this decimal and write it out as a number, 2,759. So when we write our decimal, we say and then we write this number like it's a number and not a decimal. And 2,759, and then we write this place value, tenths, hundredths, thousands, 10,000s. So we say and 2,759 10,000s. So let's write that. And 2,000, I have a comma, so I'm going to put a comma, 759, and this place value is 10,000ths. Again, I'm not going to be checking them on their spelling, but I'm going to be looking, do they have 22 million and then a comma, 25,000 and then a comma, 134. I want to make sure they're not using and anywhere else in here, only right here. And then they write, this is where most of the problems are. So they pretend like the decimal is a number, and 2,759, and then they just write the final digits place value, 10,000ths. Hopefully that makes sense. Now we're going to round. The pretest and the study guide and the learning target will all have different places they're going to round to. It was the thousands and the thousandths on the pretest. Here's the hundreds and the hundredths. The learning target will be different, so it's important they know their place value. The hundreds would be right here. Here's the 9. I'm going to look to the right. That's 5 or higher, so I add 1. 9 plus 1 is 10, so then I carry this. 4 plus 1 is 5. So let's write this out. I have 48,275,000 and then 0, 0, 0. Here's the hundreds place. Look to the right. 4 or less means I add nothing to the 2. I get 2,368,000 and